Thanks, Namrata, for the kind introduction. And thanks, Professor Dennis Lam, for having the award. And it is a huge privilege. I can't share how thrilled I am to be here today. You know, I mean, I still recall like 15 years ago when I first attended my APAO, I saw Professor Dennis Lam giving and I was thinking to myself one day, when can I start having a face-to-face conversation with this giant on the stage? And yet today I'm actually receiving the first inaugural award, and it's a huge privilege. So allow me to share some of my the lessons that I've learned, and some painful ones, and also the joyful one that I've learned in the AI innovation journey. And hopefully after my talk today, we can actually jointly explore some of the more potential collaborations with everyone here from India and the rest of the world, moving on. This is my financial disclosure. Can I just ask the hall, does anyone not know what this is? This chat, okay. So of course, when I actually was asked to deliver Professor Dennis Lam lecture, I asked Chat, as I chat, can you please describe 10 most, the greatest achievement of Professor Dennis Lam? So it's all listed there. I'm not sure whether you guys could see the screen. I apologize for the very small font because there's too many things that Professor Dennis Lam actually has achieved in his lifetime. So that's probably just the top 10. There's like many more like that. It's not shown here. So if you can check through all this list, then by the time you read point number 10, you'll be like, does he even sleep? Like, how does he do so many things like throughout his life? This is Professor Dennis Lam. So this is the photo that we took, in AAO, and I had the privilege to meet Professor Dennis and Professor Mike Chang as well in Hong Kong in APVRS. That was 2023. So I think this is something that I felt is highly appreciative, and of course, for the past many years, Professor Dennis Lam has always been a great mentor. And I'm going to spend the next 15 minutes to talk a little more about AI technology. But the last 5 minutes, I also wanted to share some of the important strategy and lessons about having mentorship, as well as how we actually build a team. Okay, so now that I asked the chat, anyone want to have the second guess about what this is? Anyone uses WhatsApp here? It's all hidden in your WhatsApp chat. So if you don't know this guy, please call him out later. So this is Meta. So you can actually counter check the chat with the Meta responses. So that gives you a double confirmation. Now, this is big. What is this? DeepSeek. So when this whale came out about a few months ago, it hit the San Francisco, the Bay, the Silicon Valley technology company by heart. All the top stocks price actually reduced by at least 15 to 20% because they felt that the GPU usage is no longer that critical. You don't need to spend billions of dollars to train foundation models. This is what DeepSeek has disrupted the space just in the recent 2 to 3 months ago. So if anyone who hasn't heard about this, you can actually search in Google. Now, does anyone not know who this person is? If you use computer, if you play games, or if you does any computing work, this is the person that you need to know, Jensen Huang. He is the NVIDIA CEO, is arguably the one who owns the most valuable tech company in the world right now as we speak. So he says that AI is not longer something good to have, but it's a must to have. And of course, this has been illustrated last year in the 2024 Nobel Prize winners, and 3 of the winners were from the computer science domains, namely Geoffrey Hinton, John Hopfield, as well as Demi Hassabis. And now, what is AI? AI has started back in 1950s. That was when Alan Turing cracked the Enigma code to win the World War II. And it comes 1980s when Arthur Samuels coined the term machine learning, and he has already stated that the computer should has the ability to learn without being explicitly programmed, without being taught, right? So now it comes deep learning, that is 2010, and the last 2.5 to 3 years, the whole world has actually witnessed the power of generative AI, started with ChatGPT 3.5, all the way to now Chat 4.5, that just released a few days ago. And if you look at this slide, it gives you a very high-level view about how rapidly the AI space has evolved for the past 15 to 20 years. It started with the numbers game, which is machine learning. Then it went on to the pictures recognition, which is the deep learning. And of course, now we talked about Chat 3.5, 4.5, DeepSeek, that is text-based. And we are also seeing the combination of the text and the computer vision, which is what we call the vision language models, coming out in the last 2 years' time. And of course, Sora, right? How do you get the computer to make the videos for you? That would disrupt the Hollywood space. It's no longer a medical, it's no longer just, having a good conversation, but you can use AI now to create movies. They can be very creative. So this is the world that we are currently experiencing right now as we speak. But irrespective of what technology or super intelligence technology that we are talking about, we all have to make sure that the bottom 4 trustworthy AI is being done. How do we train a car users to drive a car safely on the road? We don't actually need to know how to build a car, but we do need to know when our both hands are being placed on the steering wheel, we need to make sure that the car is being driven safely. This is exactly how the AI technology is going to be handled in the medical space for the next many years to come. This is just some of the AI portfolio in my lab for the last 10 years. Started with the pixel-based convolutional neural net, all the way to the multi-model generative AI space right now. So we started the first paper in JAMA. We published it back in 2017, looking at how AI could actually build the classification model to discriminate the diabetic patients who require referral versus those who do not. That was the first paper that I published in my whole entire AI career. And that was 8 years ago. And now when we talk about this, we refer them as the conventional AI techniques. It's out to date already. So this is how fast the whole AI space has actually evolved for the past 8 years. And if I plot out the whole entire journey, how do one build the AI algorithms? You have to go through the many steps from the left-hand side of the screen all the way to the right-hand side of the screen. And if you look at from the phase 1 to phase 2 to phase 3, no different from how we actually do the clinical trial for the drugs. It goes from more than 90%, then more than 95% die, and it left with less than 5%. And if you look at 5 years or more sustainability, less than 1% will survive. This is a very bleak figures, but this is what we are actually seeing for the last 15 years. And if you were to succeed for the first phase, this is the 5 rights that I've always shared with people. If you actually get these 5 rights right, you will at least get a paper out, right? We see it in a few different journals to handle some of the AI algorithms in ophthalmology, retina, the Lancet, the Nature. And this is some of the things: ask the right questions, use the right data, and of course, pick the right brain based on the questions, and then use the right architecture. And you have to make sure the primary endpoint, whether or not you're conducting a clinical trial for drugs, medical technology device, or AI technology, we are all doing the same thing. Define your primary endpoint correctly. And if you go to the next phase, how do you become the 5% survivals? So this is where we say, make sure you protect yourself. Talk to your technology transfer office. Protect your technology either as a patent, copyright know-how, or trade secrets. This is usually how we actually protect ourselves. And you have to make sure that if you were to use it in the commercial settings, you need to talk to the regulators early on. Do not wait till 3 years later, go to the regulators and then say, hey, can this work? And then they say, no, it's wrong. Then you have to redo the whole entire process again. So that's why when you actually deal with any software as a medical device technology, engage the regulators early. Whether you're going to be in US, you're going to be Europe, you're going to be Asia, China, it's the same thing. Engage them early so that you can actually design the study correctly at the outset. So this is what I usually, and then of course the last thing, who's going to pay for it? You know, like in the US, people always say, if you do not find any reimbursement code in the Medicare, do not create any AI algorithms for it. Do not wish that the Medicare is going to give you a new code for the AI algorithms, the new AI algorithms that you're going to build. But of course, we know the AI for autonomous DR software is the only one they created a new code, the 92229 code, to actually reimburse the autonomous AI screening. But we haven't seen the rest that has come out as yet. So this is something that we've done. This is the first part of my life. We looked at the classification system as I shared. We looked at the different programming codings, whether we pre-train or untrain the convolutional neural net. AlexNet just came out that time. And by the time we started trialing it, we are already using the VGGNet. And of course, after the VGG, there's like DenseNet, EfficientNet, there's MobileNet, there's many, many different nets until the establishment of Vision Transformer, right? So this is where the generative AI technology start to actually come into play. This is something that we took out from the academic settings to a startup space, engaging the regulators, getting IP filed, and then started looking at the different markets with the different regulatory requirements, and then to scale the technology beyond the Singapore shores. And this is, of course, the 3 US FDA approved autonomous AI technology as we speak. And one of the things that's quite closely related to my heart is how do we use these AI algorithms to help the underprivileged countries? The countries where you have 1 million populations, but you only have 3 doctors to serve the whole entire countries. And now we're talking about the general practitioners. We're not talking about the 3 retina specialists. How do we use a sophisticated AI technology to help the country where there is no retina surgeons or no retina specialists to screen for diabetic retinopathy? This is something that IAPB, the International Agency of Prevention of Blindness, is highly interested to look at. So this is one of my AI fellows that has just recently won the Young System Leader. We published a paper in the Lancet Global Health about the opportunities and the challenges if you were to use the AI algorithms to help screen for any eye conditions. So please look it up if those of you who are interested. So the next thing, so now that the last 6 to 8 years, we talk about how to build AI algorithms based on what the human can see. So now, the second big question now, can we use AI to do something that the human eye cannot see? Right? Can we use AI to look into the future? So this is another big question that is very, very interesting for the academic and the computer science space. In collaboration with DRCRNet, currently we are looking at questions where if you feed the AI algorithms with a fundus photos or OCT scan, can we tell not only that these patients have central involving diabetic macular edema, but also with visual loss? So of course, when we look at the picture on the left-hand side, yes, for sure, the vision is going to be bad. But what about the patients with the right-hand side photos? Some scanty heart exudates, like, radiating out from the fovea with some mildly edematous, the macula. does this patient have 20/50 vision or worse? So this is the big questions that many of the instances we cannot tell. So using about 8 protocols data sets, we managed to train the algorithms to do this. So by using just fundus photos alone, the AI algorithms have up to 85% accuracy. And if you push it with the multi-model, combining with OCT scans and patients, the risk profile, we can actually push it up to 90%. The second thing that I just mentioned, can we get AI to look into the future? Can I feed the AI with the baseline fundus photos? And we can tell this patient how likely is he or she to develop the incidence or progression of those diabetic retinopathy that needs to come in to see the retina specialist in the tertiary eye care center. This is the simple question that we ask. And we leverage on more than 20,000 eyes in the Singapore National Screening Program and found that, in fact, in the baseline photos, if you use the patient's risk profile, both as a systemic and the ocular risk profile, you could actually find these high-risk patients. And of course, if you flip it around, we can also find a very stable patients. So what does it mean? So maybe we don't actually need to screen the low-risk patient once a year anymore. And of course, we have a lot of good data that came out from the UK screening program that say, hey, if your HbA1c is very well controlled, maybe you can actually lengthen the DR screening interval to 5 years. So of course, 5 years may be too long because of the recall, the patient may forget. So this is something that we are actually looking at. Maybe 3 years is a very good interval with just an occasional nudging that we can actually already do. The other big space that our lab looking at is myopia. Myopia is always deemed to be the Eastern population problem, but as you can tell from the bar chart, the Western population's myopia rate is catching up. And there are many myopia experts sitting on the audience today that I can see now. And I'm sure everyone agrees about the trend. And we published this paper during the COVID time. It's been cited more than 400 times now. The reason why it was so highly cited was because in COVID time, as everyone sitting here know, our kids are not allowed to go to school. All the education has been converted to digital, to the Zoom educations, the Teams educations. And are we foreseeing a surge within the 2 years? We are not sure. We haven't seen the data coming out yet, but it will be very, very interesting to look at the myopia data in the next 3 to 5 years' time, to look at the myopia boomers during the COVID time. So this is one of the things that is very important for us to then think about, can we use technology to re-stratify some of these patients in the childhood space versus the adulthood space? And this is one of the papers that we published in Current Opinion in Ophthalmology to look at, if you were to use AI, machine learning, or deep learning, how do you actually build the different algorithms to look at the different clinical intended users? So the first paper that we actually published is to look at whether we can use retina imaging to predict who are these childhood population that will be high risk of developing high myopia within the 5 years, the time frame. And we leverage on more than 1,500 grade 1 to grade 6 students in Singapore. And in fact, we found that the fundus photos have a very strong predictive sign to stratify this patient to the high risk versus the low risk group. So this paper was published in Nature Digital Medicine 2 years ago. And why is it important to screen for myopia in the childhood level? Because there is treatment to prevent the childhood incidence and progression, as you can tell from the many treatments that is listed in the screen. Now, let's then move forward to my space. I am a retina surgeon. I always have to handle a lot of the high myopia related retina complications. So can we use AI and retina photos to classify myopic macular degenerations? And can we look at the fundus photos to tell whether these patients have high myopia or not? So we actually look into the Singapore data sets again, together with 6 other different countries' data sets, totaling up to more than 200,000 retina images to build the retina imaging-based AI algorithms over 10 different retina cameras. And we found that the retina imaging does have more than 90% accuracy to actually detect who are these patients has myopic macular degenerations or not. And why is it important? As I mentioned, myopic CNV can happen because of high myopia in the retina in the adulthood space. We can have macular hole that requires retina surgeries, as well as retinal tear detachment, of course. A lot of people always say, hey, if I have a sample set of 20 or 30, can I do AI? So the inherited retinal degeneration is a very good example. So I just went to the Foundation of Fighting Blindness just last month, 4 weeks ago. This is one of the papers that we presented. How do we actually create AI algorithms in the segmentation space to quantify the cyst volume in patients with X-linked retinoschisis? You do not need hundreds or thousands of data to train this. You can first train the AI algorithms using DME or CNV, but then domain adapt them into the inherited retinal degeneration space. This is what we call transfer learning. So in fact, we actually found that the AI algorithms has up to 85% accuracy to quantify the cyst, not just in the 2D space, but also in the 3D space in the volumetric values. And why is it important? Because we know not just related to inherited retinal degenerations, we can build AI algorithms to help pre-screen patients to look at the eligibility for clinical trials. That's one. And once we pre-screen them, we can ascertain the baseline. And once the baseline is being determined, we can then use that to actually continue the surveillance after the treatment is commenced and initiated. So this is actually one of the very huge potential for AI segmentation algorithms to be used in the retina clinical trials. We know clinical trials is very important. It's always cost up to 2B. That's just the average numbers. And it takes a lot of years for the molecules to go from the bench to the bedside. And we know up to 2/3 of the clinical trial fail because of the recruitment problems. We also know 50% of the site has to be shut down because they just simply cannot recruit enough. So maybe we need to look at how AI could potentially help to accelerate some of the clinical trial recruitment process from now on. And this then brings into how do we then use AI and implement AI and make sure that the AI still stay within the less than 1% space. So of course, we talk about regulatory approval just then, the reimbursement models, who's gonna pay? Is it the government? Is it a hospital? Is it the patients? Where is your AI gonna sit? Is it on the cloud? Is it on the camera itself? Or is it on your domain laptop or your desktop? So this is some of the AI implementation issues that when you use your AI, you need to know not just where your AI algorithm sits, but you also need to know where your data sits, because many countries have the data privacy rules, and this is very important. Yeah. If we were to look at the return of investment for any AI algorithms, then we have to look at the health economic analysis. No different from when the drugs got approved by the FDA. When you go to Medicare, this is something that they want any drug company to actually calculate for them. What is the return on investment for my population if I were to approve drug A for my populations? No different from the AI algorithms. When you actually present that to your chief financial officer, they will always ask this question. If I'm gonna invest $1 million in these AI algorithms, when can I claw back the return of investment? So this is one of the things that we publish the papers in the Lancet series journals to look at the 4 different pillars if you were to actually look at the ROIs for any AI algorithms. And I mentioned about the 92229 algorithms, and this is one of the things that we saw. If you have a reimbursement code, the adoption rate of any new technology will spike. And this is what we've seen for the last 2 years since the release of the 92229 code in the United States. And in Singapore, we also use and leverage on health economic analysis to tell us if we were to use AI in our national screening program, should we be using it in a fully automated way? Or can we combine the AI and the human intelligence to use a better economic model to run it? So based on the table, this is the semi-automated manner is actually the most cost-effective model. And of course, when we talk about the AI, you cannot do without the data. So this is one of the federated learning, the adversarial attack area, the cybersecurity research areas that our lab has looked at to preserve the data safety and the AI algorithm safety. And blockchain and non-fungible tokens, we also did similar research to actually look at the potential alternative to preserve the data safety. If you were to use AI, a lot of people say, is AI going to replace my job? It's going to cause fear of replacement of the job. So this is one of the surveys that we did with more than 1,000 ophthalmologists globally. And we found that if you actually position AI as an assistive tool, that is very well received by the general ophthalmologists around the world. The second last part of my talk is going to be generative AI. So this paper has been cited more than 100 times per month for the last 18 months. So we looked at the opportunity of using large language models to organize and summarize electronic medical records. A lot of people are using it to proofread, to write referral letters for your juniors and your mentees. And of course, how do we train a software as a medical device? How do we train a cornea surgeon, a retina surgeon, using the different guidelines? That is a clinical decision support tool. And if you look at the evolution of the large language model for the last 2 years, this is not the end. Every single week, there's new algorithm that comes out. And if you look at the large language model space, you can broadly divide them to the closed source and the open source. And within the closed source settings, you can look at the different sizes, all the way from more than 1 trillion parameters to less than 100 billions, to less than 10 billions, and to less than 5 billion. So this is how usually we actually look at both the closed source and the open source large language models. And when we want to optimize the large language model, this is some of the main ways to do it, going from the prompt engineering to the retrieval augmented generations and to the fine-tuning and pre-training space. And AI for patients' education. Can you ask Chat for any complicated or complex medical diagnosis? So I asked Chat, which gene therapy is approved? Yeah, Luxturna, only FDA approved, very accurate. What is achromatopsia? I'm starting to ask more complex questions. Achromatopsia is a rare inherited disorder that affects the center part of the retina. It's also very accurate. Then I said, can you make it like, more illustrious in the picture format? So then they started creating the image. And if we were to actually bring down the level to the primary grade 6 level, this is also what they can see. Achromatopsia is a rare eye condition that makes it hard or even impossible for someone to see colors. This is also very accurate. So when we talk about the foundation models, these are the 3 persons in the world that you have to remember: Fei-Fei Li, Nigam Shah, and Kurt Langlotz. And in fact, they recently was just in Singapore 2 weeks ago in the AI Health Summit that we organized. Foundation model leverage on a lot of the data sets, but the AI model can learn in the very unsupervised or self-supervised manner. They can learn by themselves. And these are some of the things that also poses some regulatory and the ethical challenges, and also the social determinants of health. How do you actually look at the patient's level, the population level, as well as the governmental level, to actually build your AI algorithms? And the last thing I want to talk about is the startup space. And a lot of the translation of AI technology from the bench to the bedside requires startup. So if you look at startup, you always have to think about the market. And this is, not sure whether how many have seen the show. This is Sadness, but of course, innovation is always fun. This is joy, right, from the inside out. Yeah, so the last 2 minutes is to actually talk about the mentorship. And I started my AI career in a very bleak manner. So I was rejected by 10 papers between 2015 to 2017. And that time, many people has casted a doubt. Why are you doing something that what a computer scientist is doing? You are MD, PhD. Maybe you should actually look at the new molecule, a new genetic mutations. Why are you looking at the computer science space? And I think family support is important. And I think finding the mentors like Tian Wong, like Professor Dennis Lam, and many others that you can see on the screen, these are some of the key mentors that have helped me along the way. They actually have found the direction and persisted when you actually are facing very, very huge significance like the downfall in your career. And of course, being in the ophthalmology space, we are very imaging heavy. That actually set a very good foundation for us to learn first within our specialty and then to step out to help with other specialty as well, leveraging on what we know. And this is some of the things I'm always thankful, because without the prior 2 to 3 slides, this is something that is not possible for me to achieve for the last many years. And thanks to Professor Dennis Lam again for nominating me for all the power lists. And it was him who has nominated me for the last many years. And that's why I was nominated. And this is something that I feel is more closer to my heart, which is the pipeline, the succession. That is what Professor Dennis Lam always has strongly advocated for. This is in my own little lab that we have already shown some fruits of success that come out in the Stanford top 2% scientists, the award, and also the different award in the Rising Star Award. And we also have garnered a lot of interest from all around the world, going from the high school students to the undergrad students, to the fellow, to the faculty to come to our lab to spend some time with us. And of course, the AI entrepreneurship, the CEOs, the CTOs, they are also very aspired to go into the innovation and the startup space to give it a try, even though they know less than 1% of the time it succeeds. And I would like to thank my team here, both from the administrator and the researcher side. And I think if you want to go fast, you always want to go by yourself. But if you want to go far, you always need a big team, a good team. And this is something that I would like to thank Namrata for yesterday for sending her student at 3 a.m. to pick me up from the airport. And this is the smile on his face, right? On the vehicle, he actually told me to get into AIMS, there's 20 million people applying for 100 jobs. And he's one of the top 100. And after you finish your medical school, you are ranked nationally, 2 million of them. This boy is ranked number 2. And the first one did not do ophthalmology, and now I think he's the number 1 in ophthalmology, and Namrata can actually justify this. And okay, with this, I want to say thank you to Professor Dennis Lam again. Thank you for giving me the first award, Dennis Lam Award, and it's a great privilege to be here to share. Thank you.